Hi there, and welcome to South Central Idaho. We are just above the Snake River here in the Snake River Plain near the small town of Bliss, which is just up on top of the canyon rim up there. And as we look down at the Snake River, we're looking at a significant geologic event that occurred not millions of years ago or even thousands of years ago, but literally a geologic event that occurred about 30 or so years ago in 1993 on July 24th. What we're looking at here is the Bliss Landslide, as it's known informally, and we can see the margin of the slide right here, and then this is all this bumpy material over to about where we see these trees come down right here. This is all part of the Bliss Landslide. If you get a chance to look at it on Google Earth, I think it's a little bit more impressive from an aerial view, but nonetheless, even from this vantage point, it's a pretty unique and scenic view of this feature that was created fairly quickly, again on July 24th, 1993. Luckily, this landslide didn't cause a lot of damage or problem for people. There's no buildings on the site. There's a bridge just around the corner over here that luckily was out of the path of the slide, and then the few homes we can see back this way were also out of harm's way. And so this slide here that occurred in 1993 probably is about, oh boy, how many, maybe about 400 meters across, 4 football fields or so, and from head to toe it's probably close to half a mile, maybe I don't know, kilometer or so in terms of its length. What's significant about this slide is down here where this gray wall is along the river. That little cut bank there represents the original path of the river, and you can see it kind of gets pinched out here, but then over again here down where this tree is over here, this is where the river was as well. So the river was actually diverted to the south towards you by this landslide. It actually not only constricted the channel, it actually cut off the Snake River for an hour or so until the river was able to cut a new channel through. But it was able to divert the river, and in the process it created a rapid down here, which doesn't look very big, but there's some nastier stuff just out of view below this embankment right here. And at high water, this is one of the more formidable rapids on this section of the Snake River called the Hagerman section, with waves and hydraulic features that approach probably class 3 plus, probably getting between class 3 class 4 types of rapids. But this gives us a nice view of the expanse of the slide. We can see that on the rim here we have dark basalt. As we go over to this side, we can see the same thing. And yet, as we look at the slide itself, we're not seeing a lot of dark material except way back there along the rim, and that wasn't where the slide initiated. The slide actually initiated several hundred feet or meters, from that point up there. So it looks like this slide has failed or occurred within this kind of beige colored material here. And what we're going to do here next is we're going to see a couple places here. We're actually going to go over to the east side of the slide and get a nice vantage point there where we can see some of this material up close and personal. So we'll start over there so we can get a better sense of actually what type of material, geologic material, failed during this mass wasting event. And then we'll head down here along the river to these exposures down here in these old cut banks along the river and see what they have to tell us about the story. So join me as we head back up here to the east, and we'll see you up there. Okay, we're now just on the east margin of the Bliss Landslide. Here we are looking kind of back to the north to the sort of origination point for the slide and where it's failed. We can see some of the trees out here, but more importantly, we can see this kind of lumpy, bumpy ground, this irregular terrain. This is what geologists call hummocky topography. And this type of terrain and topography is often indicative, or one of the characteristic features that we see associated with slides or mass wasting features. We can see the Snake River down here. We just shot the first part of the video just past that line of trees on that small hill overlooking the river. We got the bridge down here as well. And so now we're looking at the actual slide itself, and the road that we're on up here, which is the old Bliss grade that takes you up to the rim here, actually provides us some nice access and outcrops of this material. So we can see the nature of this slide, its irregular terrain, where it originated and flowed. We have the basalts up above rimming the canyon, and these are called the McKinney lavas, or the McKinney basalts. They erupted about 50,000 years ago, and they're going to play a factor in our story here. But let's maybe talk quickly about why this event occurred. You can actually see the river coming in from this side, and it actually takes a pretty sizable turn here, a nearly 90-degree swing in the path of the river. And if you know a little bit about hydraulics and how rivers behave, you know that the outside bend of that path of the river is the one that's going to have the highest velocity and cause the most erosion. So we can then speculate a little bit here that the river, over who knows how many years, has been slowly eroding and cutting into the toe of this slope. There was actually another slide here that predated the 1993 slide, a slide deposit that was dated by geologists. I'm not sure if a date on that was ever determined. So ever since that slide occurred, the river's been eating and eroding away at the toe or the downstream end of the slide. We can also look up towards the town of Bliss, look at some of the houses and the trees up there. And of course, in southern Idaho, a lot of the industry is agriculture. And so we've got farms up there, we've got irrigation going on, and as that water seeps down into the crops and into the groundwater, it wants to eventually escape, and in this case it's headed down gradient towards the Snake River. And so we could also then, possibly a factor involved in the slide would be the enhanced water supply in the groundwater caused by the irrigation of the agricultural fields above. But this material has failed and slid. I believe 1993 was actually a wetter than normal year, so that might have played a role as well. We've got the river undercutting, so there might have been a host of factors that led to this slope failure here. But let's actually take a little walk across the road and look at this little outcrop here in the road cut, because this is the material that this slide occurred in, this beige colored material. Again, we're in the Snake River Plain where volcanic rocks tend to dominate, but we've got something very different here. We can see that it's beige colored. It looks like it has some layering to it. So it looks like there's some bedding involved. And if we actually kind of get into this stuff, it's actually quite soft. We can break apart blocks of it pretty easily. We can excavate pieces of it. And so let's look at this stuff a little bit more closely. Here's a nice little block right here. So as I feel this with my fingers to the touch, it's obviously quite soft and crumbly. I can more or less pulverize this all in my hand. In terms of grain size, this does not feel sandy. This feels much finer than that. This is clay, or I suppose, you know, being almost a rock, you might call it a clay stone. But this is essentially weakly consolidated clay material. And so this material is notorious for causing mass wasting events. It shrinks and swells depending on how saturated it is. When it gets wet, it actually expands and swells, and when it dries out, it shrinks. So it's actually really tricky to put roads across this stuff. If we take a little piece here and put some water on it, the particles of clay are so fine that it doesn't actually absorb a lot of the water. And so what happens then is it becomes super slimy, just slippery. I'm sure you've all driven on a muddy road. Maybe you've got stuck in the mud in your truck or car. This is the material that causes this material to fail. It becomes super slippery and lubricated when it gets wet. So the real question here now isn't, we've sort of just talked about the factors for the slide. We've looked at some of the material itself, this clay-rich material. This is actually a formalized stratigraphic unit called the Yahoo clay. And it's interesting because this clay material crops out here just south of Bliss, and it extends along the Snake River Canyon maybe another 10 miles, 16 kilometers or so. And that's kind of it. You only find it in the canyon for the most part. And you only find it along this short stretch here. So I think the next question we want to answer is, well, how did this stuff get here? Why is there so much clay in the canyon? What's the story of this material that basically led to the Bliss landslide? And to answer that, we're going to have to go back further in time to about 50,000 years ago. And we're going to have to go down by the river itself. So our next little clip here will be down along the Snake River. And we will pick up our story from there and we'll tie it all together. Okay, so we're down here on the banks of the Snake River, looking east at the toe of the slide. So this little projection of land right here is the portion of the slide that came down into the Snake River, filling in the original channel, which was over here, and effectively diverting the Snake River to a new path, a more narrow path. And that's why we see a little section of whitewater through here. All the water's concentrated into a small channel where there's some rocks and other obstructions that make for some whitewater. And at high water, believe me, I'm a rafter, that thing gets pretty big and kind of spicy. Looking back to the west, we can see Shoestring Bridge, or what's sometimes known as the Bliss Bridge. And the first part of our video was up here on this ridge, looking back to the north. But we're at the toe end of the slide, and what we want to point out here is the rocks along the rim are basalts that erupted from a shield volcano, I don't know, maybe 10, 12 miles away, called McKinney Butte. And so McKinney Butte erupted 50,000 years ago, and its lavas came south and west and flowed into the Snake River. So it actually flowed into this canyon, which was already here, and came off the rim and flowed into the river itself. And in the process of doing so, that event, that lava flowing into the Snake River, constructed a dam. When lava mixes with water, it cools the lava very quickly. It quenches the outside of it, and you get what's known as pillow lavas or pillow basalts. And down here along the edge of the Snake River, we can see great examples of these pillow lavas. So as we come down here, you can see these rounded shapes, in some cases almost forming little toadstools and such. Here's a nice classic one here, showing some of the radiating fractures that you typically see. We can also see that the rock is heavily brecciated. It's broken into lots of fragments. But this is also McKinney basalt. It's also 50,000-year-old basalt, the same as we see up on the rim. But here, the basalt and the lava interacted with the river, quenched the lava quickly, fractured it, fragmented it. In some places, it was somewhat explosive because the gases trapped in the lava eventually built up and then burst out. And what this did over time, as that lava kept coming from that volcanic eruption, is it built a lava dam. So the prolonged eruption of McKinney Butte produced enough lava to fill up most of the Snake River Canyon and make a lava dam. So we are looking at the guts of that lava dam. The brecciated basalt, the rounded pillow lavas that form in here. We've got a couple of these close by. We can kind of see the glassy rind that kind of forms along the edge of these pillow lavas. So the top of it's really glassy. The interior is a little bit more fine-grained, so we can actually see some crystallization there. But these pillow lavas just form all along this cliff band here. All the kind of rounded, bulbous shapes that you're seeing in here are all part of that lava dam. Another really nice one right here, showing the outer kind of glassy surface of the basalt. And then as you come over here, you can get a good view here in the interior, you can see the rind along the outside, and then on the interior it's more like the typical kind of gray, dark gray basalt that we expect. One more really good one I just saw up here. Try to get the lighting just right. Let's see, we'll come over here. There we go. So again, this beautiful rind here where the lava is in contact with the water, cooling and quenching to form this sort of glassy outer carapace, and then the interior staying molten, cooling a little bit slower, forms a little bit different texture here. So there's a nice outer edge of that pillow lava there. So let's put this all together with some diagrams and a really nice graphic from a book I helped work on. Let me come up here to my notebook. Again, more of these just beautiful glassy pillow lavas kind of embedded in this palagonite breccia. So here's my attempt at a cross section from north to south, kind of showing what's going on here. Let me grab the pen to point some things out. So on the north, we have the McKinney basalt forming the rim rock. Beneath the McKinney basalt, and we can't see this exposed anywhere, but there's other exposures up and down the canyon, is some lake sediments from the Pliocene called Glenn's Ferry Formation. These are somewhat noteworthy because this is the sedimentary unit that has the Hagerman fossil beds paleontological resources. So that national monument nearby owes its existence to this formation and the diversity of plants and animals found within this. So these are sedimentary, horizontally bedded lake beds that forms the substrate beneath the canyon. The McKinney basalt pouring over the rim, eventually encountering the Snake River. I just sort of chose an arbitrary point, and where you see these little circles forming, that's meant to show pillow basalts and pillow lavas, where the lava dam was. So that would have extended across the ancestral Snake River. Now behind that, so if you think about, if you're damming up a river, what are you forming on the upstream side? The water's ponding, you're essentially forming a lake, and that lake's been called Lake McKinney. And so in that slack water of that lake, behind the lava dam, we would have calm water, and the fine material that the river's carrying, like clay, would then settle out on the bottom. And so that forms the Yahoo clay, which is just a thin veneer that sort of coats the surface of the ancestral Snake River Canyon surface there. So that's the material that felled in the slide, the Yahoo clay, which is sitting on top of the pillow basalts. Sometimes it's interbedded with it a little bit, and sitting on top of the Glenn's Ferry Formation. That's the material that slid, diverted the Snake River from its original path a few hundred feet to the south to where it is presently. So hopefully a helpful cross-section there, kind of showing how the geology today looks. One more diagram here. I kind of have this laid out. We'll walk up the hill, hopefully get away from the noise of the river, up through these river gravels, and look at a sequential diagram that kind of explains the whole story. This is out of two books of mine, Geology Underfoot in Southern Idaho, and also Roadside Geology of Idaho. So we'll start here with an ancestral Snake River and the eruption of lava from McKinney Butte. So here we can see the lava encroaching on the canyon, heading south and west towards the river itself. That lava continues over the rim. Where it interacts with the water, it forms pillow lavas. You'd see steam coming out of the river as some of that water is vaporized to steam. So we'd get our pillow lavas forming there. Eventually, as that eruption continues and lava continues to flood into the canyon, we would get an effective lava dam forming across the Snake River, backing up water behind it to form Lake McKinney. And at the bottom of this lake, eventually we would see these fine-grained deposits of clay, these bedded deposits of the Yahoo clay here at the bottom of Lake McKinney. Now, we don't know how long this lake lasted, but looking at the thickness of the clay, what some people have speculated on is perhaps this lava dam was a little bit leaky, because if you just effectively seal off the river, dam it up, you'd probably fill up a lake pretty quickly that would overtop the lava dam, breach it, and that would be the end of that story. But we think that this lava dam was able to persist for some period of time, maybe a few years, maybe a few decades, and that this lake was here for some time as well, forming these clay deposits then that sort of line the ancestral canyon profile here at the bottom of the lake. And then eventually we get to today's scenario, where eventually the river breaches the lava dam. Of course, the Bonneville flood came through here and probably removed a lot more evidence as well, but we can still see patchy remnants of the lava dam along the river corridor like we just did here a few minutes ago. We can also see patchy remnants of the Yahoo clay immediately with or upstream of the lava dam, just like we did at the middle part of this video along the roadway there. So a really nice summary of the Bliss landslide, and not just how this slide formed in 1993, but also going back to this older event 50,000 years ago, where a lava dam invaded the Snake River Canyon, dammed up the river, created a lava dam, which then produced a lake where clay was deposited behind it at the bottom of that lake, and then eventually that clay set the stage for the 1993 slide that we saw at the beginning of the video. So hopefully this was helpful, kind of a fun little story and investigative work to piece together an area and a story that probably doesn't get very much recognition, that most people don't know about. So hope you enjoyed it from the scenic banks of the Snake River here in South Central Idaho.